Welcome back, students, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 10, the 10th experiment, which is called electrical conductivity of aqueous solutions. So, the first thing you want to do is you want to make a copy of the lab report from our Bright Space course and edit the document on Google Docs, or you can download it and edit it on Word and then re-upload it to our Bright Space. So again, the first thing you want to do is on the lab report put your name and the date in which you are completing the lab for experiment number 10. And the directions for this lab is that in the box below we are going to write a sentence that clearly describes the goal to complete the experiment. So the objective for today's experiment is to determine which common aqueous solutions conduct electricity and to classify each sample as a non-electrolyte, weak electrolyte, or strong electrolyte by observing the brightness of a conductivity apparatus bulb when the leads are immersed in the solution. Again, the objective is to determine which common aqueous solutions conduct electricity and to classify each sample as a non-electrolyte, weak electrolyte, or strong electrolyte by observing the brightness of a conductivity apparatus bulb when the leads are immersed in the solution. So pause the video, make sure to write that objective, and we are going to be going to the next section. So the next section, as always, is we are going to list the equipment and their function that we will be using for this experiment. So the first equipment we'll be using is the conductivity apparatus. And the conductivity apparatus, the function of it is that it completes the circuit. Bulb brightness shows relative conductivity. And we're going to see that in today's experiment. The brightness of the bulb will tell us whether a substance conducts electricity or does not conduct electricity. 50 milliliter beakers. It will hold each prepared aqueous sample for testing. Distilled water, solvent for making solutions, and rinsing leads to avoid contamination. So that's one error we might encounter, is that contamination. If we think a substance conducts electricity where in fact it doesn't, it's because probably there was some left over on the lead. So again, distilled water. Next up we have clean scupula and stirring rod. So the function is to transfer and dissolve solids to prepare homogeneous solutions. Safety goggles, as always, safety is important. It protects the eyes from splashes or reactions. And last but not least, we have the waste container, which collect and dispose of used solutions safely per lab rules. Now, let's talk about the theory behind today's lab. The first word is aqueous solution. An aqueous solution, by definition, is a homogeneous mixture that contains a substance and liquid water. A homogeneous mixture means everything is mixed evenly. Everything is in one layer. As an example, salt water. You put salt in water, it will mix evenly. So that's an aqueous solution. So the water is considered the solvent, so the water is the solvent, and the substance is called the solute. So whatever you're dissolving in water, we are going to call it the solute. Solutes could be ionic compounds. If the solute is an ionic compound, it's considered salt. For example, sodium chloride is an ionic compound and is also considered a salt. Or covalent compounds like sugar. We're going to talk about sugar today, and sugar is a covalent compound that does not conduct electricity. Now, electrical conductivity, the definition, again, if you see anything that's bolded, that's important. Electrical conductivity is a physical property in which electricity can flow relatively easily through a material. So, materials that have high electrical conductivity are going to have a strong electric current, but materials that have low electric conductivity are going to have weak electric current, and materials that have no electric conductivity are going to have no electric current. Now, sometimes aqueous solutions can conduct electricity because when they are dropped in water, they are going to dissociate or break into their ions. Ions are charges, and the movement of charges can allow the substance to conduct electricity. Now, this is the conductivity apparatus we're talking about. So we have the light bulb, we have the leads right here, and then we have the sample to be tested. So this is going to help us determine if electricity can flow through a sample such as an aqueous solution. And if electricity flows, that means this, you see, the circuit is going to be complete. And if it is completed and there's conducts electricity, the light bulb is going to be bright, which tells us it's a strong electric current. If you see dim light, that means it's a weak electric current. If there is no light, that means there is no electric current. Once the apparatus is plugged in, a sample can be placed between the leads so that it makes physical contact with both of them. If the light turns on, the sample can conduct electricity. The amount of electricity or the brightness of this bulb can flow through the sample will affect the brightness of the light. So the amount of electricity will affect the brightness of this light bulb. So the experiment here, we are going to determine whether different aqueous solutions could conduct electricity using this conductivity apparatus. One, we are going to plug the conductivity apparatus to an outlet. We have to make sure that not to touch the leads with our hands, or we will get an electric shock. Prepare all the aqueous solutions in their separate beakers using clean scupulas and transferring everything to the beaker. We're going to position the beaker with the solution under the conductivity apparatus, and we're going to immerse it on the apparatus. Now, on our data sheet, you're going to write down whether you see no light, dim light, or bright light in your observation column. So if we go back, so you can see the data sheet right here. So for your observation, you're going to say, is it no light, dim light, or bright light? And as a conclusion, is it no current? Is it weak current? Or is it strong current? So we are going to be doing it for all of these solutions, all of these mixtures that you see on the left. All right. Oh, they made us go back all the way to the beginning of the presentation. All right, here we go. So as you can see, no light, dim light, bright light, no current, weak current, or strong current, and will be, so you should be filling out your data sheet as we are doing this. So the first thing we'll do is we have table salt, baking soda, and table sugar. Now, at the observation, if you see, let's look at table salt. All right, so we're gonna put salt. Look at that. Is this no light, dim light, or bright light? You can see this is bright light, and which signifies strong current. This is a strong electrolyte. So sodium chloride is one of the strongest electrolytes. Sodium chloride. See, and you have to rinse the leads so that we don't have any contamination. That was table salt. Next one is baking soda. So we have some now baking soda, which is sodium bicarbonate. As you can see in the video, we have a small amount. Now the sodium bicarbonate, it's a solid. Does it conduct electricity? And the answer is not as a solid. It does not conduct as a solid. So let's try to dissolve it and let's see if anything special is going to happen. So baking soda does not conduct as a solid. But let's see if we mix it up. We're dissolving it, we're breaking it apart, and let's see. Oh, so baking soda conducts electricity as a liquid, but not as a solid. So you're gonna write bright light, strong current. It's a strong electrolyte, baking soda. Yeah, and as you can see, a very important summary. it did not conduct as a solid, but it conducted when it was dissolved in water. So bright light, strong current. Next up we have is sugar, table sugar. So let's see. We're gonna take some sugar with the formula C12H22O11. So here we got some sugar, and now we are going to see, does sugar conduct electricity as a solid? And the answer is no. So substances do not conduct as a solid because the ions are not free to move. Let's dissolve the sugar. Let's see, is it going to conduct electricity or not? So now we're going to mix the sugar in water, mix it up, mix it up, mix it up. All right, let's test it. Let's test it. Sugar does not conduct electricity as a solid or when it's dissolved in water. And the reason is sugar C12H22O11 is a covalent compound. Covalent compounds do not conduct electricity. So for this one, you're going to see no light, which means it's no current, which means it's a non-electrolyte. Very good. Moving on to the next. So here we have the next section of chemicals that we will be testing. The next one is hydrochloric acid, which is a strong acid, the acid found in your stomach. Now, let's see, do acids conduct electricity, especially hydrochloric acid? So we have a sample, and look at that, very much conducts a bright light, and it's a strong current. This is one of the strongest electrolytes. So hydrochloric acid does conduct electricity. Next up, acetic acid, which is a weak acid. Hydrochloric acid before was a strong acid. This is now a weak acid. It does not break up completely. So let's see. Weak acid is going to be bright, no light, or dim light. You can actually, acetic acid, uh, it, it is not, as you can see, the light bulb is not turning on, not even dim. So for this one we're gonna say it's, oh, but see, it's changing. Look at that. As we're adding a little bit of water, look at that. It's changing. It's changing. So adding the water is helping the acid. But notice we had to add, so by now it's conduct electricity. So acetic acid will be considered a weak acid. So you're gonna say dim light and a weak current. Notice we had to add the water in order to help the acetic acid conduct electricity. So acetic acid is dim light and weak current. It's a weak electrolyte because it's a weak acid. It does not break up completely. All right, next up we have ammonia, which is a base. So how do we get ammonia? Is by mixing ammonium hydroxide. So this is an ammonium hydroxide is a solution of ammonia in water. Ammonium hydroxide. Look at that. Ammonia. There is no conductivity. But let's see by adding a little bit of water. Let's see, adding a little bit of water makes the light a little bit dim, just like the acetic acid. So the water is, it's a very interesting. So it is weak on its own, but the water helps a little bit. So we're gonna say this is dim light, weak current. Ammonia is considered one of the weak bases. So it's not a strong base, but it's a weak base. Ammonia, dim light, weak electrolyte. Next up, we have ethanol, which is an alcohol with the formula CH3CH2OH. Ethanol is an alcohol. Let's see, is it no light, dim light, or bright light? Again, you can write. So we got no light. Let's see by adding the water, is it gonna help? If we add the water, is it going to help? And more water is added, and you see the light bulb is not turning on. So ethanol is no light and it's no current. And the reason is ethanol is an is a alcohol, And alcohols are covalent compounds. They're straight up covalent compounds that they do not break when they go into the water. So ethanol would be no light, no current, non electrolyte. Next up, we have calcium hydroxide. If you look here, calcium is on the left of the periodic table, Ca. It's a metal. Hydroxide is OH, and OH, the oxygen and the hydrogens are nonmetals. So when you have a metal and a nonmetal, you have an ionic compound. Let's see if this ionic compound is going to conduct electricity or not. And also, calcium hydroxide is one of the strong bases. Let's see. Is it going to conduct electricity? So we're shaking it to make sure everything is fully dissolved. We're going to pour a little bit of calcium hydroxide into the beaker. Let's see. Let's see. Let's test its conductivity and notice it does not conduct electricity, which is interesting. Calcium hydroxide, even though it is a strong base, it does not conduct electricity. The metal and the nonmetal are so tightly bound that they do not break apart when they go inside of water. So we're going to say, based on our observation, it's no light, no current, it's a non electrolyte. Next up, we got magnesium hydroxide. So let's see magnesium. When we test it with magnesium, what's going to happen? All right, we have a beaker now filled with magnesium hydroxide. Let's add it. And again, magnesium. So group two metals are not breaking apart. So we're gonna say no light. Let's see, we're adding water. Nothing's at no light, no current. So group two bases are very interesting. They do not conduct electricity. Group two bases. So we did calcium, we did magnesium. They do not conduct. How about if we tested group 1 bases like Na? Sodium is in group 1. So NaOH. Let's see. Sodium hydroxide. Sodium hydroxide is classic. Strong base. Oh, look at that. Yes, the classic one. Bright light, strong current. It's a classic. So as you can see, group 2 bases do not conduct electricity, but group 1 bases conduct electricity. So you should have completely filled out your data sheet by now. And the next section you want to answer is the summary. Make sure you write in one or more paragraphs. You want to summarize the results of this experiment, write in full sentences, avoid using bullet points or sentence fragments, describe any trends or patterns you observed in today's experiment, make an effort to support your statements by referring to the theory that we discussed in the pre-lab. For instance, make sure you talk about how can we conclude if a solution can conduct electricity. Make sure to tie it back to the apparatus that you looked at. That includes the light bulb. So if the light bulb becomes more bright, that means the substance conducts electricity. You got to support your statement with examples from the data from today's experiment. That some announcements and reminders. You're expected to complete the following by the assigned due date. You already have watched the experimental video. All you need to do is now complete the quiz that's based on the experimental video that's going to be posted on Brightspace, and make sure to submit the lab report using the given template, and make sure to complete all the sections of your lab report. Thank you and see you soon.